Why model rest area clearance? There is a point in CNC milling, and it is time. Being accurate is one hand, having no collision is another hand, and make your operation and make your piece in the fast possible time is another hand. So for start a machining, for make it quicker, for make it faster, most of the time you have to start with the biggest tool which you have. For example, it can be a 50 millimeter holder or 63 millimeter or any kind of holder or tool like that. But a big holder, a big tool, make you be able to done your roughing very much quicker than the smaller tool. But the bigger tool has a bigger radius, and may your model have a sharp corners, and you have to continue roughing with a smaller tool, not in all space, but specifically in that areas which the bigger tools not be able to make it done. You have to just detect that areas and start machining these areas to make your piece ready for finish. As we talked before, for finishing you need a semi-finish. And what it may be semi-finish? A semi-finish is an operation that makes your remaining material in all over your piece same as similar together. For example, in all piece, in all part of your model, you have for example a 10th or 3/10 of millimeter remaining bar, and we call that semi-finish. So as I said, after a quick roughing with a big enough tool, you have to detect the corners which the bigger tool cannot be able to machining that places. So model rest area clearance is just about that topic, detecting the remaining areas to machining with a smaller tool. In that case, we have several situation. We have some different situation, which it depends to our status. We're going to choose one of those which are suitable to our machining. We have three kind of rest machining which is usually used in machining or in programming in Powermill. The number one is use with rest boundary for the most simple models. As we talk about it, I'm going to show you how. In some simple models, you already know just a few corners have a remaining material, and with from boundary header you choose the rest boundary, and there is some option which you have to set them. You have to introduce your previous tool, your reference tool, the first tool which you start roughing with it, and after that you have to introduce your next tool, the smaller tool which you want to continue roughing with that. And after that you have to certain the tolerance of the boundary calculation that I want you for any kind of boundary use 100 of millimeter every time as a tolerance. At least don't use the bigger numbers. It gives you a better quality. And after that, in any kind of strategy which you think it will be suitable for your workpiece, you can use it and see the result. For most of the time, when I use model area clearance, when I use rest boundary, most of the time I use constant Z finishing or maybe raster finishing. This is on your hand. It depends to your model, and it depends to anything which you think is a matter. This is on you. This is totally on you. This is number one. Number two is a rest model area clearance. It the behavior of model rest area clearance is completely similar to model area clearance, but it just used on some specific areas which your previous tool cannot be able to machining that areas. But how to detect that area? How we have to detect that area? This is a two-way. The number one, again, for the not important model, not complicated models with a less risks. This is a faster way, but I never use that way, but I have to introduce to you that way. When you tick the rest machining on model area clearance, a header usually will be added on your toolbar at your left, which named rest. On that toolbar, on that header, you have to detect, independent of what you want to make a rest area clearance. You have to choose your previous model area clearance which you use at once, and independent of that you detect some others. You have to set some other options like detect remaining materials more than what this is on you for example, I usually use at least 1 millimeter for 50 diameter tool and 5/10 of millimeter for a 6 millimeter tool. This is on you, and you can calculate your rest area clearance. It would be for example, easy way. But there is a third way which is very more perfect and with a more accuracy, with a more this is very perfection. And what is the third way? The third way is like saying the two, but we use rest model area clearance again. But for introducing the remaining area, you shouldn't introduce the previous toolpath. You have to introduce a stock model. Just you have to go to the stock model header and choose new stock model. And after that, in opening window, you have to set some setting. Mostly I use 500 of millimeter as a tolerance, and it depends on how much details you want to your stock model. If you want to continue rest area clearance with a very tiny end mills, like for example 2 millimeter, 1 millimeter, you want to continue your rest modeling, you can use, for example, 2/10 of millimeter as a mesh factor. And I can't remember what was the name exactly, but I definitely show you here. And after creating a stock model, you have to introduce your block as a material, and you can add your any toolpath which you want into your stock model, and after pressing the calculate option, the Powermill will calculate how should be your stock model, how should be your model after doing that kind of strategy on your model, on your stock model. And independent of that, you can use and create your model area clearance. It is some benefit to using a stock model against introducing your toolpaths, and you may ask what it may the benefits, what kind of benefits. In model area clearance, when you introducing the previous toolpaths, you can't introduce many toolpaths. Okay, you can just introduce one toolpath. And the other things, after creating your first toolpath, you may detect and delete a part of your first strategy. You may detect and delete some segments of your previous toolpaths, right? But when you use toolpath as a reference for your rest model area clearance, you definitely have some collisions, because it's not detect your deleting segments. But when you use a stock model, each kind of editing or deleting your previous toolpaths, for example, if you delete some segments or if you cut some segments, it would definitely have an effect on your new rest model area clearance, and it the cause which avoid of any collision. So that's the point. And you can use your finishing strategy as a previous strategies in a stock model. You can see the effect of your some other, for example, finishing strategy. You at first you use some finishing strategy for roughing. Which is so common, using constant Z finishing as a rough strategy. It is common, but you can see the effect of constant Z finishing in the first way. But in second way, which you adding your previous strategy, can be compared of some model area clearance or no, some finishing strategy. You can add them too, and you can see the effect of them too in your new rest area clearance. So that's the difference between the using model area clearance with a stock model or not. And also we talked about why we have to see and use rest model area clearance, because it make us be able to make our produce very faster. Okay, there is no need to using our smaller tool from the beginning or make a very big and difficult finishing for just as a rest strategy. We can with rest area clearance and using rest boundary or using rest area clearance with a toolpath as a reference or a stock model as a reference, we are be able to make our produce and make our operation more faster done. And it is the value, it is the very valuable matter to us for using model rest area clearance. Okay, I am Hossein, this is a CNC with channel, and that was a short video about model rest area clearance. That was a short video about learning Powermill. If you have any question, you can leave a comment. If you're interested to this kind of video, you can follow this channel. And I have to say, if you're interested to this kind of video, I'm going to introducing you some other common strategy in Powermill in a few common weeks. And after that, we're going to research the most simple model to the most complicated model, and see how we have to start machining, how we have to start programming them from the start till the finish. So thanks for watching this video, and goodbye.